carrying on with solving simultaneous equations on page 293, section 20.2, this time by substitution method. Again, we've done this before in Unit 2, so let's just go for it. Question 1, solve these simultaneous linear equations by substitution. I'll just do two of them. Let's just do 1c first of all. I'm given r equals 2p minus 5, and I'm given p plus 2r comes to nothing. But if I want to substitute, I reckon the easiest thing I can do is to take this term here, the 2p minus 5, and stick it right there where the r is, because r equals 2p minus 5. So if I do a substitution along those lines, this is what I'm going to get. I'm going to get p plus 2 lots of whatever r is, and that's of course 2p minus 5, and this equals 0 because I've substituted into the second equation here. Multiply out, so we've got 4p minus 10 equals 0, so 5p minus 10 is 0. I'm sure we can see where this is going. 5p equals 10, so p equals 2. Easy. So let's just substitute the p equals 2 somewhere simple in order to access the answer to r. If I shove it in there, and I've got it in the form of r equals straight away, so let's squeeze it in over here. So r equals 2 lots of 2, take away 5, 4 minus 5, answer r is minus 1. Beautiful, isn't it? Right, let's just do d as well, working over here. Stick to yellow, I think. It's getting all dark when these are lovely little mountains in Fuerteventura. It's a volcanic island, it's as dry as anything. If you want some heat and some lovely breeze, go there. Anyway, I've got v equals 2w's minus a half, or 0.5 as they say, and I've got 4v's equals, sorry, no, not equals, 4v's minus 5w's comes to 1. So I reckon, again, if I shove in this term here, this 2w minus 0.5, right into there where the v lives, I've got 4 of them. So let's just substitute and go. So I've got 4 lots of v, which is 2w minus 0.5. Then I've got to take away 5w, because that's what it says in the second equation there. All comes to 1. Multiply out. 8w's minus 2. 4 times a half is 2. Take away another 5w's. That's what it says. So we've got 8 take away 5. That gives me 3w's. Minus 2 is 1. Look how beautiful this is working out. Take the minus 2 over and add it, of course. 1 plus 2 is 3, from which w is 1. That is a beautifully crafted question. Well, if w is 1, why don't we take it and stick it right in there? And I think I'll work on this side now. Let's change couleur. So I've got v equals 2 lots. Oh, where did the blue go? Anyway, v equals 2 lots of w, which is 2 lots of 1, and take away a half, 0.5. So I've got 2 take away a half, answer 1.5 or 1.5. And that's question 1, C and D done. I'll do question 2 on the other page right now. Now how about some blue? Goody, it works. I presume these are going to be more challenging because it's question 2, not question 1. So this is 2C on page 293. 7x minus 2y comes to 4. 6x plus y comes to 17. And I'm told I've got to do it by substitution again. Now that's not very helpful, is it? Because I've got 2y. Alright, listen. How about I go y equals 17 minus 6x. Is that alright? I've took the 6x over. And now I can substitute this 17 minus 6x term where the y is right there, alright, and get an equation with just x in it. So that will become, again, you get quite creative the way you're going to do it, but do it the easiest way possible. I try to find the easiest route through. It helps in life. Right, let's shove it in the top. So I've got 7x minus 2 lots of whatever y is, which is that little blob there. 17 minus 6x, and that should all come to 4. So it should come to 4, and so therefore I write down 5. Should come to 4, says so 4 it is. So multiplying out then, 7x is not attached to the bracket, so 2 17s we minus 34, because, you know, minus 2 actually, and minus times a minus is going to be a plus, so it's plus 12x's, and that will come to 4. 7 and 12, 19x's, 4 plus the 34, of course, taking it over to the other side. Again, it's working out really nicely, as you can see. 4 plus 34 is 38. When we divide by 19, we get an answer of 2, which is lovely. Now, got to work out what y is worth. Well, look, since I've already rearranged it like that, why not stick this x equals 2 right there. Why not? So I've got y equals 17 minus 6 lots of 2. Yep, dead easy. 17 take away 12. Y is 5. Special, isn't it? Let's just do D. Hopefully it will fit here somewhere. So here's D, working in yellow. Right, 2e minus f is 22. 3e plus 2f comes to 40. Let me try and make that 2f look more like a 2f and not like a whatever it looked like. 2f. Right, if I play around with this equation right here and take the f over to the other side and bring the 22 over, I'm going to get f equals 2e minus 22. So what I did was I took the minus f over and added, and I took the 22 over to this side and subtracted. So I ended up with 2e minus 22 equals plus f on the other side. So that's that. I reckon if I shoved this term here, the 2e minus 22 term, right here, I get an equation with e's in it. So off I go. Let's just do that straight away. So I've got 3e plus 2 lots of f, which is 2e minus 22, sorry, not plus 22. And that will come to 40, it says, doesn't it? Tidying this up a little bit, 3e plus 4e multiplying out, minus 44 equals 40. That's 7e, isn't it? 7e, and that will be 40 plus the 44 from the other side. So 7e is 88. Sorry, 84. And I don't know what 84 divided by 7 is. So I'll now pick up my calculator because I'm in Unit 3. So let's just do it quickly. Switch on. 84 divided 7. Oh yeah, bang on, 12. Love it. So therefore, E is 12. Now let's get the F as well, shall we? Right, where can we put this then? I reckon if we shove it in that, that'll be really nice. So I'm going to work over here now. Just there. I've got 3 lots of 12 plus 2 F's comes to 40. And I'm working with this equation right here, alright? So what we got then? We got 36 plus 2 F's comes to 40. 2 F's is going to be 40, take away the 36. Let's not run out of space, please. So 2 F's is 4, and for the grand finale, F is going to be 4 over 2, 2. So there's me 2 answers. I'm sorry I've got like 2 questions on one screen and it's all over the place. Well, this is just me working in rough, and you can do it ever so nicely in an exam. Now question 3, which is several pages on, I believe. Yeah, there it is. Question 3 is a real beaut. I'll do this one and then stop because the video is likely to get a little bit long, isn't it? So here we go, question 3. Now, it's a lovely, lovely question. This, when you see it, it's a circle theorem. It says the diagram shows a circle with centre x. Yep, with that little black blob means that's the centre, and therefore that's a diameter. All right, diameter. Hint: the angle formed by the triangle at the circumference is x plus 3y. Great big angle there. I don't know why they've gone so large. All they had to do was like that, really. But anyway, and I'm told that x is 30 more than y. Now, please note, if this was an exam question, you would not be given this hint. From this and your knowledge of circles, you would not be given that. All right. Now, this is the textbook. It's page whatever it is, 293, question 3, grade B rated. Now, you won't be given that, but clearly, if you're seeing triangles trapped in circles and maybe the odd tangent here and there, then you've got to think circle theorems. But this is a very creative question out of context. You don't normally get simultaneous equations in the context of circle theorems. So that's the preaching done. Right, from this and your knowledge of circles, hint, hint, write down 2 equations in x. Let's just do that quickly. Well, here's an easy one here. X is 30 more than y. In other words, I reckon y add on 30 is x. How's that? That's that, isn't it? Now, you should recall, if this is a diameter, because it passes through the centre, then the angle at the circumference is 90 degrees. That is my bit of circle theorem. Therefore, I've got x plus 3y comes to 90. Isn't that lovely? Absolutely beautiful. That's meant to be a y, not a g, just the way I did the pen arrangement there. So let me sort that out a little bit. There you go. X plus 3y comes to 90. 1 equation, 2 equations, I've got 2 marks. Now we should do some solving. Let's write them here first. I've got y plus 30 is x, and I've got x plus 3y is 90. Well, straightforward. Look, I can see that x is y plus 30, so why not take the y plus 30 and shove it right there where the x is? So I will do that. So I've got y plus 30, that's x, plus 3y is 90. Altogether, 4y plus 30 is 90. Take the 30 over next one and subtract. 4y comes to 60. 60 divided by 4, 15 degrees. Beautiful, isn't it? Now what about working out x? Oh, dead easy. Look at this. I've got y plus 30 is x. So x is going to be 15 degrees plus the 30 degrees, 45 degrees. That is a lovely, tasty question. There you go. X is 45 degrees, y is 15 degrees. Now, just as an aside, I reckon, let's go to green because it's just not part of the question, the x plus the 3y should come to 90, shouldn't it? It says so. Let's just test it. So x is 45 plus 3 lots of 15 comes to, does it come to 90? Well, that's going to be, let's put the equals on this side, I reckon. So it stands in the right sequence, so that's going to be 45 plus 3 15s are 45. What does it come to? 90 degrees, so we got it right. I think I give myself 3 marks for that. Yeah, you don't need to do that in an exam if you're confident with your final answer, but if you're going to test it out, then obviously it needs to come to 90 somehow, because such is circle theorem. Alright, so I'm going to stop there. I went a bit quick, but we've done loads of these right the way back from Key Stage 3. Alright, so I'll now prep some of the more dodgy ones.